Yeah, a lot of people over time have asked me some tips on building dry cells, and NoBox is now going to build a neutral dry cell, so I'm just wanting to put all the tips I've had in other videos and everything I've learned about the dry cell all into one video, just a quick reference so everybody can have their questions answered from this video rather than me typing to everybody's inbox. Alright, so when we talk about dry cells, we're referring to these type of stacked plate cells where water enters through a bottom hose, floods up in between all the plates, electricity makes the gas and comes out the top hose. So you need a reservoir containing the electrolyte with hoses that connect to the bottom part of the dry cell, and then hoses returning up to the same reservoir to release the gas, and then hoses carrying that gas to whatever you want to do. Alright, so that's out of the way. Now, the dry cell itself is made with stainless steel plates. Now here's a whole bunch of tips that I've found in making dry cells. Okay, so first of all, the type of stainless steel you want to use, if you want to have a cell that's not going to deteriorate and you're going to keep for a while, don't waste your time with any other low-grade stainless steel that you find at Home Depot or any of that stuff. Get 316L stainless steel, and that's the best you can go with. Those things outlast 304 by miles. They don't react the same to the electrolyte. They don't deteriorate as fast at all, and you get much better production out of 316L for some reason. So, and you reduce the risk of hexavalent chromium, which we'll talk about after. But anyway, so use 316L plates no matter what you're building, unless you were trying to make some little cheap quick cell, then it doesn't matter. But if you want something that's going to last, make your plates 316L, very important. Alright, so focusing just on the plates again, another thing you want to do is you got to drill a hole in the bottom and the top of every plate. And that's going to allow all the gas to go through your bottom hole to flood with water, and the top hole is going to allow the gas to escape out. Alright, now the issue of the positioning of the plates. Now I've found most people make their dry cells where they're sitting rectangular or square like that. And what I found was that when the water level comes down, there's a big column of stainless steel plate that is not flooded at that moment. And I found by taking the plates and just twisting them into a diamond shape like this, that allows the most amount of water to cover the plates, keeping the amperage up and the production up. And Scarecrow said he never got much production difference doing it like this, but for some reason I did. Maybe it was just the way the cell was built better or something, this one, but using a diamond shape got me a little better production. And it always kept the amperage constant, kept that up, and it kept the plates flooded all the time. Alright, so on the top of every power plate that you want to use, you got to cut out a little rectangular male piece that female push-on connector will slide onto. It's very simple. Next time I make one, I'll just show a quick video how easy it is. You just use like a Dremel tool or a rotary tool and put a cutting wheel on it, and you can just cut out whatever shape you want. It's very simple. On this diamond cell, I knew I was always going to use 5 neutral plates between each power spot, so I just have it set up like this. But normally I would have it cut out like this mini dry cell is, so that I can have 5 neutral plates between every power supply, or if I want to use 4 between each, I can just detach these and reattach where I've cut them out here to get a 4 neutral plate configuration. So now people will refer to their configurations using terms like 5N3, 5N4, 5N5, or what they're saying is, like for instance, this diamond cell is set up in a 5N5 configuration, meaning you can see between every 2 power spots there's 5 neutral plates. So there's 1, 2, 3, 4, 5 sections where there's 12 volts divided between 5 neutral plates. So that means there's 5 cells running here basically. So you have 5 neutral plates, which is the 5N, and 5 cells. So 5N5 is this configuration. If there was only this much, it would be a 5N3, because you still have 5 neutral plates between each cell, but there's 3 cells making the gas, and so on and so on. So when you hear people saying that, that's all it means. So this cell you can use 5N3 or 4N3. So it's a very good idea. The point is that if you want to change your configuration, you want to cut out the appropriate terminals so that you can change from a 5N configuration to a 4N configuration. And the reason that you're changing your configuration is simply based on whatever power source you're using. If it's an alternator from a car, it's going to be about 13.8 volts. Same with the battery chargers that I use, they're not a little higher than 12 volts. So when you know your power supplies in that range, you want to use the 5N configuration. That'll divide the voltage properly, so you'll get between 2 and 2.4 volts per plate gap. If you're using it straight off a charged battery, which gives you 12 volts or a little bit above, you want to go to a 4N configuration. So that's the difference why you want to have the option of just taking off your terminals and putting them onto a different spot to change the configuration, because you may be using different power supplies and you want to either have an alternator or a straight battery running at different times. With this diamond cell, I know I'm always going to have the same power source running this, so I didn't bother adding the other options to make it 4N because it would be useless for me. But future dry cells that I build are all going to have that, and yeah, it's very useful. And if I forget to mention that, everybody has all these little prepping techniques for their plate. Just make sure they're very clean. All I do is just soak them in vinegar and distilled water, and then wipe them with a microfiber cloth, because even a thumbprint left on the surface of the plate will stop production where your thumbprint was left. So make sure that your plates are very clean as they go in. You don't have to go through all kinds of sanding and all kinds of crazy stuff. I see people prep their plates for like days before they put it together. I haven't found that to be beneficial. I wasted lots of time doing stuff like that, and I didn't find any benefit. Just keep them clean, use 316L, and that's it for the plates. Now the gaskets that we use for this is neoprene gaskets. You just buy a big sheet of neoprene gasket material. It's not expensive. Make sure it's 1/16 thickness. And the reason you want that is because any cells 31 plates or less, you can use a 1/16 plate gap and it works perfect. That's what I use. If you want to go above this, you're going to take the 1/16 neoprene gasket and double it up in every spot, so now you got a 1/8 gap between every plate. So when you get to higher plate numbers, you want to use a bigger plate gap. Now, as you'll notice on my dry cells, the bolts that hold everything in place that run through here don't actually run through the plates. On the EBN cells, the bolts run right through the stainless steel, but I find that to be a lot of drilling. So this works out really great. Just go around the perimeter, but when you're drilling your holes in the acrylic or whatever you're using at the front, you got to be very precise that you're lining those holes up properly to make it fit snug, so that you don't find out later when you're putting it together that it doesn't fit properly, and then you're going to be in a mess. So just be precise with your holes that you drill. This is simply just that rigid water hose that you can buy at Home Depot or anything like that, and works perfect to insulate any threaded rod. I use stainless steel threaded rod just for the simple reason of why not use something that won't rust. It just makes sense. And stainless steel nuts and washers, and they even have a rubber backing so that the metal doesn't push right against the acrylic, just so there's no cracking when I tighten them. And I don't have to use this, but I use a 1-inch thick acrylic piece, which I think is an overkill for this, but I wanted to make sure that the shell was very solid because it has to hold the weight of these stainless steel plates. So I think it was worth it, but in the future I'll probably go down to 3/4 inch or even 1/2 inch.